All right, welcome back. Today we're going to talk more about exponentials and explicitly the inverse of an exponential and what happens. Remember, when we have inverses, our x becomes our y becomes our x. Remember that they are reflected in the y equals x line. All right, let's go to page 594. So here we have an exponential 2 to the x, and they've plotted some points for us and made the graph. All right, let's go down here and talk about this graph a little bit. So the domain of this exponential goes from negative infinity to positive infinity. Let's write that down. The range, well, the range starts at 0, right? We don't include 0, and then it goes forever upwards, right? There's that asymptote there. The y-intercept, if you remember, anytime I plug 0 in, it gives me a 1. So my y-intercept here is 0, 1. Let's talk about x-intercept. Does it have an x-intercept? Not in this case, right? Because we have this asymptote on here. Now, sometimes we could have these where we shift them, but in this case, we don't have that. All right? So the asymptote, we talked about that, is y equals 0. Because at y equals 0... it approaches that but never touches it, all right? It looks like it is touching it, but it's actually never going to touch that. Intervals of increase or decrease. Well, this is always increasing. And when is it increasing? It's increasing on its entire domain. So from negative infinity to positive infinity. And the end behavior. So let's talk about the end behavior. As x goes to negative infinity, my y values approach 0, right? They approach that asymptote. As x goes to positive infinity, my y values approach positive infinity, okay? So now over here, you'll notice they took the x value, made it the y. They took the y value, made it the x, and they plotted it, and just like I promised, y equals x, it is a reflection in that line, y equals x. So what I want you to do is pause the video, and I want you to fill out all of these all these things for the inverse of that exponential. All right, go ahead right now, pause the video. So they are true inverses here, right? Our range became the domain of the other one. From 0 to infinity is our domain of the inverse. Our domain became the range of the inverse from negative infinity to positive infinity. We had no y-intercept. It's never going to touch the y-intercept, but it is going to have an x-intercept at 0, 1. Whoa, pardon me, 1, 0. All right, and it has an asymptote at the x equals 0 here that it approaches but never touches. It's always going to increase. It's going to increase from 0 to positive infinity. This one's a little different. This says as x approaches 0 from the right, because when you look at this, there's two sides to this, right? As x approaches 0, I'm approaching it from the right side. So I have to say that plus, and what that plus means is I'm approaching 0 from the right side. So if I said as x approaches 0 from the negative, from the minus, that'd be from the left side. So as I approach it from the right, where does it go? It goes to negative infinity. And where does it go when it approaches positive infinity? It goes to positive infinity, all right? Now, this is a special function, all right? The inverse of an exponential is actually a special function, and what it's called is a logarithm, all right? A logarithm. So, a logarithm looks like this. Log base 2 of 8 equals 3. I always think of this as the exponent. They say the logarithm or the exponent. This is called the argument, which honestly, I just learned this year, all right? So it is the log base 2 of 8 equals 3, all right? We can write them, and it's really important that we can go back and forth. So just as 4 is a base, it's a base when I write the log, all right? Whatever it equals becomes my argument, and the exponent becomes what it equals, all right? So the base is 10. The base over here of the log is 10. The argument is whatever that equals, and the exponent is the equals on this side. Base, base, argument, argument, exponent, exponent. Just like that. So let's talk about some restrictions. Are there any restrictions for x? So when I have this right here and this right here, are there any restrictions for that? Well, no, x can be any real number, right? When we had exponentials, I could put negative numbers in there, I could put 0, I could put positive numbers in there. I could have any real number. Well, now let's look at b though. We talked about this with exponentials. B has to be greater than 0, right? And b cannot equal 1. So that's going to hold true for logs as well. So when we have a base of 0, we can't do that. We can't do anything of 0 or negative bases, and b cannot equal 1. So if you saw log of 1 of 10, we know we couldn't do that, okay? And the reason is when we had this, we talked about exponentials. This multiplier here is always going to be positive. And if it's a 1, it doesn't make sense because 1 to any number flatlines. It doesn't actually make that curve. That's why we can't have b equals 1. So then what would y equal? Well, y is going to have to be greater than 0. It's going to have to be all positive numbers. All right. This again is just for the basic one. We're not talking about if we shift it or move it or things like that. All right. But when we had our basic exponential, our y's were always greater than 1, right? All right. All right, over here they talk about this triangle of power. I really think this triangle of power is no good. So I'm not actually going to show you how to do it. What I do want you to understand is I want you to be able to change from an exponential to a logarithmic. So I'm going to do log. This is my base, and this is my exponent. My base always becomes my base, all right? And I always think about it this way. So this 3 could either go here or here, right? Well, if it was 2 to the third, wouldn't that just be the same thing? It doesn't make sense. So the exponent always goes on the other side, and then it becomes 8. So this is saying 2 to what power equals 8? Well, 2 to the third power equals 8. So the log base 2 of 8 equals 3. All right? Let's do this one. It's the same thing. All right? We could write this as an exponential to solve it. 2 is my base. X is my exponent to my argument of 8. So 2 to what power equals 8? X would equal 3 because 2 to the third equals 8. Same thing here. My exponent, my base is x. X to what power equals 8? Well, what number to the third power equals 8? 2 to the third power equals 8. So 2 would equal x there. So let's try this one. I'm going to do A and B, you do C. All right, so I'm going to rewrite this as an exponential. So 10 to the x power equals 1,000. What 10 to what number equals 1,000? 10 to the third equals 1,000. So x equals 3. Over here, 5 to the fifth power equals x. What is 5 to the fifth power? 5 times 5 times 5 times 5 times 5 is 3,125. All right, so go ahead and pause the video and draw the last one. All right, so I said the base is x, the exponent's 1, and equals the argument of 9. So x, what number to the first power equals 9? Well, that's 9. 9 to the first power equals 9, so x equals 9. Very nice. Let's go back and talk a little bit more about graphing these logarithmic values, all right? So a logarithmic function is a function involving a logarithm. Whoa, that makes complete sense, all right? So the first thing it says down here in number 1 is to sketch the graph of the inverse of h of x. So we're going to sketch the inverse here. That means what? It means my x has become my y has become my x, right? All right. So instead of the point -2, 1 over b squared, I'm going to have 1 over b squared and -2. Somewhere in here, it's got to reflect in that line, right? Instead of the point -1, 1 over b, I'm going to have 1 over b and -1. Instead of 0, 1, I'm going to have 1, 0. Instead of b over 1b, I'm going to have b1. Instead of 2b squared, I'm going to have b squared 2. Right? So I have a graph that looks a little bit something like this. Now, let's talk about this. Exponentials, they go up rapidly, right? The y's grow quickly. All right? So I want you to think about that. The gap here from this y to not big, not big, not big, but it grows bigger every time, right? So that means for a logarithmic graph, what's going to happen? Our x's are going to grow quickly. So the space here is not big from x to x, but it gets bigger every time. The x's get bigger. So it won't go up as fast, but it will go this way much faster. The y values won't increase as much as the other ones. And sometimes when you look at a table of values for a logarithm, you're like, wow, the y's don't increase at all after a while. It does, just barely, all right? Down here in number 2, it says write the equation for the inverse. All right, well, let's write the inverse. So this is x equals b to the y. All right, so we need to rewrite this. All right, I need to get y by this. I need to rewrite this. So log base b of x equals y, right? So the inverse is log base b of x, right there. All right, on page 598, it says, do you think all exponential functions are invertible? Well, let's take a look. They could look like that. They could look like this. They could look like this. They could look like that. They're all invertible because they all pass the horizontal and vertical line test, right? So all of them are going to be invertible. All right, now a very big thing here is what is called a common log. So there are going to be some times where you see numbers just like this. All right, and what that is saying is there's no log base written. Whenever the base is not written, it's a base of 10, and it's called the common log. So if I have log of 1,000 equals what? I would do base 10 to what power equals 1,000, and we already did that one. We know x would be 3. So log of 1,000 would be 3, okay? Much like that, we also have what's called the natural logarithm, a natural logarithm. And that's when we have log base e. Remember, we learned about e last time, e to the first being much like pi, all right? It's in your calculator, the digits you can find. So whenever I have log base e, I don't write log base e, I write the natural log, ln, natural log. I know it's reversed. I think it's reversed because it was French. I don't know, logarithm naturale, whatever, all right? All right, so they want us to graph these two things here, all right? And we have log base 2 and log base 3. Well, I know that the natural log of x is the log base e of x, and I know that e is between 2 and 3. So guess what? Its graph is going to go between 2 and 3. All right? So that would be the natural log of x. And I know that log of x is the same as log base 10 of x. And so you remember, when I went this way, the bigger the base, the faster it goes up. So if it goes up faster, now it's going to go over faster. So you see how it goes down? 2e3. So I know that 10 is going to be somewhere in here. All right, somewhere lower because it's going to get over to the right faster. All right? All right. Last but not least. All right, let's go and talk on page 602. I know we skipped a few things, and that's okay. And let's talk about the basic characteristics of these things. So the basic function for an exponential is f of x equals b to the x, right? And for a logarithm, it's g of x equals log base b of x. The graph is going to look something like this. And the graph of this one is going to look something like that. All right? Now, I want you to fill out the rest of this with the knowledge you have. All right? So pause the video and fill that out. All right, in fact, I want you to complete that for homework. All right? That's going to start your homework. So your homework is going to be page 602, complete that table. All right, and look for why they're inverses. All right, is the x the y, the x, things like that. We'll complete that table. On page 603, you're going to do number 1. So you're going to do number 1, all parts, A, B, C, and D. All right, and then on 604, you're going to do just the stretch. Just the stretch here at the bottom of the paper. Just try it out. Rewrite them, see what you can get. Maybe solve for this and then solve for that and see what you can do. All right, just try them out. All right, so that's today. Good luck. Remember to ask questions and go out there and do your best. We believe in you.